So now I have to read the short answers, and I have to get every single one. I'm just retaking one of them because I got all the short answers, but I just left out like one word on one of them.
I have to get all of them right to get a deal wrong.
All the
Because the multiple choice did not help me. I mean, I honestly did better, but for some reason it did not improve.
All right. Let's wrap up standard B today. I got one last little lesson on using chain rule to find derivatives of trig functions that have multiple inner functions. Inner functions within inner functions. Be very careful on how you write this because I want to make sure that I take the derivative of each function that represents my given function. All right, so for example, let's do this. I want to find the derivative of f of x equals sine cube of 4x plus 1. Sine cube of 4x plus 1. I think the best thing to do when I want to take the derivative of this is to think about this cube power. What is being raised to the third power using this trig notation? The whole thing. Sine of 4x plus 1 want to be cubed. So let's write it as this. Sine of 4x plus 1 the third power. Oops, I forgot the 4 on 4x plus 1. Now, general power rule states that I can find the derivative by using n times u to the n minus 1 times u prime. General power rule, we're going to bring down the power times the inner function to the one less power than was there before times u prime, the derivative of what's on the inside. And be very careful how you do that because there's going to be a couple of different functions that make up this inner portion, what's being raised to the third power. F prime of x equals, all right, so bring down the 3 times the same thing times u. This is the u we're referencing. Sine of 4x plus 1 to what new power? Now multiply times the derivative of u. Multiply times u prime. What is the derivative of sine 4x plus 1? Let's take this one piece at a time. What's the derivative of sine? So we're going to multiply times cosine of 4x plus 1. Multiply times what else? What other function makes up that inner function? There's an inner function within the inner function. Sine of 4x plus 1 is one of the inner functions, and inside that sine 4x plus 1 is another function, the 4x plus 1. So I need to multiply times the derivative of 4x plus 1, which is another. There's the expanded form version of our derivative. Spend a little bit of time cleaning it up. Let's see here. 3 times 4 is 12. I have a couple of trig functions. Sine of 4x plus 1 squared, or sine squared, 4x plus 1, times cosine 4x plus 1. There are multiple inner functions. I'm raising sine of 4x plus 1 to the third power. And that inner function is made up of 2 different portions. The sine portion, which I differentiated as cosine 4x plus 1, times what's inside that sine function, the other inner function, Functions within functions within functions. So also make sure you differentiate times the extra 4 given as the derivative of 4x plus 1. A couple more of those. These really come about when I have these kind of trig function type derivatives to find. Powers of trig functions, where I have functions within functions within functions. So I want to find the derivative of g of x equals tangent to the fourth of x squared. I think the best thing to do is to think about what is being raised to the fourth power. Let's write this as a power function so I can use power rule. What is being raised to the fourth power? Tangent of x squared, the whole thing, right? We just always kind of put the 4 here, so I don't mix up and say, all right, it's x squared raised to the fourth power. That's kind of confusing using that notation.
Juniors and seniors, if you're interested, at 1:30, there is a virtual admissions rep available from Mount Mercy University. There's a Zoom link in your email that Ms. Hopkins sent you. Juniors and seniors, at 1:30 today, Mount Mercy University will have an admissions rep available via Zoom, and you can find that in your email.
If I didn't put the 4 there, it might be kind of ambiguous if I put the 4 on the end. Am I taking the fourth power of x squared? Am I taking the fourth power of the whole thing? So that we don't make that mistake. Notation says write the fourth power next to the tangent, but then understand I'm also raising the tangent of x squared to the fourth power. So g of x equals tangent of x squared to the fourth. Use power rule. What's the inner function? What is the u in this case? Tangent x squared. So that's the u. I'm going to use my power rule formula with n, bring down the power, times u to the n minus 1. But then be very careful how you find u prime, because tangent of x squared really has 2 different inner functions, the tangent portion and the x squared portion. So g prime of x, let's actually start finding the derivative. 4 times what? Okay, so that's taking care of part of this. I've got the power portion differentiated. Now I have other things going on inside that power function. I have to multiply times the derivative of these inner functions according to chain rule. Secant squared of x squared. That represents the derivative of tangent. Now what else? Which is the other inner function, x squared. So I believe I can multiply a couple things together. 4 times 2x, or 8x, times tangent cubed x squared, times secant squared x squared. I'll have you guys do one more on your own, and then we'll get some practice. Let's do that. Cosine cubed 1 minus 5x, find the derivative. People always struggle with these, but I think it's a little bit easier to write it as a power function first. Cosine of 1 minus 5x, all raised to the third. How'd you, Jane?
What?
How'd you do?
I think I did it right.
You crushed it?
Yep.
Does it match the blue?
Yep.
Incredible.
Mhm.
Incredible. Strong. This one might get people tripped up on the negatives. What's the derivative of cosine?
Yeah.
So watch the negatives here. Bring down to 3 times cosine of 1 minus 5x squared now times the derivative of cosine minus 5x, which is negative sine 1 minus 5x. Times what else? People always forget this. Negative 5 because where? I'll multiply a few things together here. 3 times negative 1 is negative 3 times negative 5 makes positive 15. Like I said, those multiple inner functions, multiple functions, functions within functions within functions come about kind of this unique trig type functions we're looking at differentiating. Let's do this. Grab your laptops. Let's talk about plans for the next couple days.